Hello everyone, I am Miss Pilotos and today I will demonstrate solving volume world problems in calculus. We will cover the disk method, shell method, work, and length. Once again, hello and welcome to my class. We'll learn calculus math for today. Let's begin! Before we dive into the examples, let's briefly overview what we will cover. We will learn how to compute volumes using the disk and shell methods, calculate work, and determine the arc length of a curve. Understanding these methods is crucial as they have numerous practical applications in fields such as engineering, physics, and mathematics. First, let's discuss the disk method. This method is used to find the volume of a solid of revolution by revolving a region around the x-axis or y-axis. The volume is given by the formula V is equals to pi times the integral from a to b of the radius of x squared dx, where r of x is the radius of the disk at any point. Let's solve a problem using the disk method. We need to find the volume of the solid obtained by rotating y equals the square root of x from x equals 0 to x equals 4 around the axis. Using the formula, we set up the integral as v equals pi times the integral from 0 to 4 out of the square root of x squared dx, which simplifies to pi times the integral from 0 to 4 of x dx. Solving this, we get pi times the quantity x squared over 2, evaluated from 0 to 4 equals 8 pi. Next, let's look at the shell method. This method is also used to find the volume of a solid revolution, but it involves revolving a region around the y-axis or x-axis. The volume is given by v equals 2 pi times the integral from a to b of x times of x dx, where f of x is the height of the shell at any point of x. Let's solve a problem using the shell method. We need to find the volume of the solid obtained by rotating y is equals to x squared from x equals to 0 to x equals 1 around the y-axis. Using the formula, we set up the integral as v equals 2 pi times the integral from 0 to 1 of x times x squared dx, which simplifies the 2 pi times the integral from 0 to 1 of x cubed dx. Solving this, we get to 2 pi times the quantity x to the fourth power over 4, evaluated from 0 to 1 equals pi over 2. Next, let's discuss the concept of work in calculus. Work is defined as the integral of a force function over a distance. The formula is W equals the integral from a to b of f of x dx, where f of x is the force applied at point x. Let's solve a problem involving work. We need to calculate the work done to stretch a spring from x equals to 0 to x equals 2 meters if the force required is f of x equals 5 times newtons. Using the formula, we set up the integral as w equals the integral from 0 to 2 of 5x dx, which simplifies to 5 times the integral from 0 to 2 of x dx. Solving this, we get 5 times the quantity x squared over 2, evaluated from 0 to 2 equals 10 joules. Lastly, let's look at how to find the arc length of a curve. The length of a curve from x equals a to x equals b is given by L equals the integral from a to b of the square root of 1 plus the derivative of y with respect to x squared dx, where the derivative of a y with respect to x is the derivative of the function describing the curve. Let's solve an arc length problem. We need to find the arc length of y equals 1/3 x to the 3 halves from x equals 0 to x equals 4. First, we find the derivative dy over dx equals 1/2 x to the other half. Plugging this into the arc length formula, we get L equals the integral from 0 to 4 of the square root of 1 plus 1/2 x to the 1/2 squared dx, which simplifies to 1/2 times the integral from 0 to 4 of the square root of 4 plus x dx. Using substitution, we set u equals 4 plus x and integrate, resulting in 1/3 times the quantity of 8 to the 3 halves minus 4. To the 3 halves equals 1/3 times quantity of 16, 8 times the square root of 2. In conclusion, we have covered how to solve problems using the disk method, shell method, work, and arc length calculation. Each of these methods is essential for understanding various physical phenomena and mathematical concepts. I encourage you to practice these techniques to deepen your understanding and proficiency. Thank you for your attention. I'm happy to answer any questions you may have or discuss at any point. We can discuss it further in the comment section. Bye.